So we're even now a little bit further into the sedimentary Appalachians. We're in the vicinity of the emplacement thrust fault that carried the rock from the last stop, along with a few kilometers of additional material, and emplaced that thrust sheet on top of the footwall thrust sheet that's just to our northwest. What you're seeing in the outcrop here is meter to tens of meter scale deformation. There is folding that's apparent here. A lot of it's covered by vegetation right now. But really in this part of Appalachia, in the foreland or the deformed foreland and the fold thrust belt, the only time you're going to see sort of outcrop scale folds is going to be in the vicinity of a significant thrust structure. And these are sort of small horse type blocks whose deformation at this scale is possible because they're pretty thin little slices that are moving within the fault zone. By and large, all of the other rock in this area is not really penetratively deformed. You're not going to see the meter to centimeter or even smaller scale folding that we saw in the initial metamorphic outcrop, and you can still see some evidence of in the slate grade outcrops that we were just at a few kilometers back to the southeast. So the pattern of deformation you see here does tell you that you must be in the vicinity of a pretty significant thrust structure, and although this does separate two very distinct thrust masses, it's not really as significant of a boundary as the one between the slate grade rocks and the sandstones that we just saw. From here all the way to the structural front, the forelandmost edge of the fold thrust belt, thrust faults are juxtaposing units that are less and less distinct in terms of their burial history because transport on the thrust is lower and lower, and it's bringing units from different lateral and vertical positions, shorter and shorter distances, to put them on top of the footwall units. When the vegetation is off of this outcrop, there's actually a very beautiful detachment fold. You can just see a bit of maroon in the center of the view there. That's a little bit of shale that's been sort of pinched up into a fold hinge, and that's actually coming up off of a thrust plane that itself has been deformed slightly. There are actually several thrust splays within this outcrop. The structure is very complex, and that's just something that's diagnostic of one of these thrust zones here within the more external parts of the Appalachian fold thrust belt. Okay, so we've moved a very short distance to the northwest from the previous stop, but we've passed into a geologically very, very distinct and different zone of the Appalachians from the previous stop. What we're looking at here are sandstones. These are probably uppermost Devonian in age, possibly lowermost Mississippian, but the real story here is the burial depth that these materials reached. It's significantly less than the somewhat slaty rocks we saw in the previous stop, and that's because we've crossed another very significant thrust fault that emplaced those what you might call proto-metamorphic or borderline metamorphic rocks on top of this material, which is most certainly purely sedimentary rock. We're not looking at really any extent of recrystallization here. This is all cemented detrital grains. This material would have been buried less than 10 kilometers at its deepest burial point. The slaty material from the previous stop would have been buried certainly more than 10 kilometers at some point in its history. Another way of visualizing that, or sort of bringing that into the context of how these rock units are laid out, is that slaty material was emplaced into its present position many, many tens of kilometers along a very high displacement thrust. The material that you see here is part of a distinct thrust mass in the footwall of that slaty stuff. This has not moved nearly as far from its original depositional position, sort of on the edge of Laurentia, or what we today call North America. So we're now fully within the sedimentary Appalachians, what we call a valley and ridge, and even though the previous stops where we look at that borderline metamorphic slate type material looks like part of the valley and ridge topographically, it's just because the rock is very erodible and susceptible to solution where carbonate is exposed. It does produce a topographic valley, but the units that you see just southeast of where we are in the hanging wall of the thrust we just crossed have more in common really with the crystalline sheets on which we started this trip, where you saw the chlorite-rich rocks, the amphibole-rich rocks that were buried 15 kilometers or more and represent sort of the crystalline interior of the Appalachians. And indeed, anywhere you go now to the northwest for literally hundreds of kilometers, the only rock you will see in outcrop is sedimentary material that's been buried less than 10 kilometers, and in many cases, maybe just 5 kilometers or so.